In this video, you'll learn how to effectively serialize PyTorch models using TorchScript, a critical skill for deploying models in production environments.
Welcome to the first step in mastering PyTorch model serialization using TorchScript. Did you know that TorchScript is a powerful tool designed to bridge the gap between PyTorch's flexibility and the efficiency required in production environments? In today's fast-paced tech world, deploying models seamlessly across different environments is crucial. Serialization, through TorchScript, not only optimizes your model but also ensures compatibility, making it a must-have skill for data scientists and engineers. Stay tuned as we dive into the world of TorchScript and explore practical, real-world applications. TorchScript is a powerful tool that enhances PyTorch models for deployment. At its core, it converts PyTorch models into a format known as intermediate representation, IR, which can be optimized and run in different environments. There are two primary modes of using TorchScript: tracing and scripting. Tracing works well with models that have a static computation graph, while scripting is more flexible, handling models with dynamic control flow. Understanding when and how to use each mode can significantly impact the performance and compatibility of your models. Let's delve into these concepts and explore their practical implications.
Model serialization offers numerous benefits that are crucial for deploying machine learning models in production. By converting models into a serialized format, you significantly enhance their optimization potential, leading to improved performance and reduced latency. This process also ensures cross-platform compatibility, making it easier to deploy models across various environments. Whether you're working on a mobile app or a large-scale server deployment, serialization helps streamline the process, facilitating smoother, more efficient model deployment. Let's explore these benefits in detail and understand why serialization is an indispensable part of the machine learning workflow.
Tracing a model with TorchScript involves capturing its computations and generating an optimized graph. Start by defining a simple model in PyTorch and running it with sample inputs to ensure its correctness. Next, use the torch.g.trace function to convert your model into TorchScript. This step generates a graph that represents the model's operations. Finally, save the serialized model for deployment. By following these steps, you can efficiently trace your models, paving the way for seamless deployment across various platforms. Let's break down each step and see how to implement them in practice.
Scripting in TorchScript allows you to convert models that include dynamic control flow, which is not possible with tracing alone. Begin by using the torch.g.script function to convert your model into TorchScript, ensuring that all dynamic behaviors are preserved. This approach is particularly useful when your model includes conditional statements or loops. Additionally, you can combine scripting with tracing to handle complex models effectively. Once scripted, save and load your models for deployment. This guide will walk you through the detailed process of scripting PyTorch models, ensuring they are ready for production use. While serialization is a powerful tool, it comes with its own set of challenges. Common pitfalls include data type mismatches and handling non-deterministic operations, which can lead to unexpected behaviors. Unsupported layers in TorchScript may also pose a problem. Debugging these issues requires a clear understanding of your model's architecture and the TorchScript framework. Ensuring model accuracy after serialization is crucial, and regular testing can help catch errors early. This section covers these common pitfalls in detail, providing tips and strategies to avoid them and ensure a smooth serialization process. Optimizing serialized models is crucial for effective deployment. Start by reducing the model size through techniques like model pruning and quantization, which can significantly improve inference speed without sacrificing accuracy. These optimizations help in deploying models on resource-constrained devices, such as mobile phones or edge devices. Additionally, thorough testing of the model's performance post-optimization ensures that the deployment meets the desired criteria. In this section, we'll explore these optimization techniques in detail, providing actionable insights to enhance your model's efficiency and performance in production settings. Let's look at some real-world examples of successful serialization projects. These case studies illustrate how various organizations have leveraged TorchScript to deploy models effectively. We'll discuss the challenges faced during serialization, the tools and techniques employed to overcome them, and the lessons learned from these experiences. By examining these projects, you'll gain valuable insights into how serialization can impact deployment positively, highlighting the practical benefits of using TorchScript in production environments. Get ready to be inspired by these success stories and apply their lessons to your own projects. Serialization is a complex process that can be simplified with the right tools and libraries. This section provides an overview of the available tools, both native to PyTorch and from third parties, that can enhance your serialization process. Understanding how to integrate these tools with PyTorch and choosing the right one for your specific needs is crucial for maximizing their benefits. We'll explore some popular libraries, discuss their features, and guide you on how to incorporate them into your workflow effectively. This knowledge will empower you to streamline your serialization efforts and optimize model deployment. Maintaining model performance after serialization is key to successful deployment. Regular evaluation of the model's performance is essential to ensure that serialization has not impacted its accuracy or efficiency. Monitoring performance metrics will help you identify any changes or degradations in model behavior. It's also important to update models as needed and maintain detailed documentation and version control for your serialized models. This section outlines best practices for maintaining model performance, ensuring that your serialized models continue to deliver optimal results in production environments.
Congratulations on completing this comprehensive guide on serializing PyTorch models with TorchScript. We've covered the essentials of tracing and scripting, optimizing models for deployment, and avoiding common pitfalls. Serialization is a critical skill that enhances model performance and compatibility, making it invaluable for deploying AI solutions. As you continue your learning journey, consider engaging with the community for support and collaboration. Don't forget to like, share, and subscribe for more in-depth tutorials, and let us know in the comments what topics you'd like to explore next. Your feedback helps us create content that meets your needs.